Okay, hi, thanks for watching, and I am now going to teach you how to do null hypothesis testing for proportion. So we're given a problem here that leads two candidates are running for the mayor of a small town, the current mayor and the challenger. And an exit poll of 200 randomly selected voters, 115 had voted for the challenger, and it wants to know, is there convincing evidence at the 1% significance level that the challenger will win the election? So the first place to start to solve a problem like this is you have to state or describe the population parameter being tested. So in this case, the population parameter being tested is the proportion of voters in exit poll that voted for the challenger. Right, since it wants to know basically will the challenger have enough votes to win the election, so it wants to know the proportion of voters in the exit poll that voted for the challenger. So now that that's identified, you have to do step 2, which is to state the null hypothesis. Actually, let's go back and label the first step, which was to describe the population parameter being tested. So now we have to state the null hypothesis, and the null hypothesis, the symbol for that is HO, or we can actually record it HO like that, or um, so yeah, H0 actually record it as that. So H0. And for null hypothesis, it always has to equal something. So in this case, we want to know, does the challenger have enough to win the election? So the null hypothesis will equal 50%, because you have to have more than half. So the null hypothesis would be he has exactly half. So 0.5. Step 3 is to state the alternative hypothesis, and this is labeled as HA. And HA has to be greater than or less than something. In this case, it's asking, does he have enough? So we'd have to have more than 50%. So we want the alternative hypothesis to be greater than 50%. And you'll see here I wrote it as a decimal. You could write it as a percent, but you'll see later that it's more helpful to write it as a decimal right there. So step 4 is to select the significance level. And usually in a type of problem like this figure will be given to you. So you can see here, it asks, is there convincing evidence at the 1% significance level? So significance level is labeled with A, so we'll make A equal 0.01. This can be labeled with a lowercase a. So step 5 is to identify the test statistic. For proportion, it will always be this z value, and that's going to equal p hat. Usually this hat is above, but since I'm typing it, it leaves it like that. But that's p hat minus po, or p0. That just means the hypothesized proportion divided by the square root of 1 minus P0 divided by N. So that's the formula you have to use to actually calculate this Z value. So step 6 will be to check the assumptions with the associated test statistic. Actually, before we do that, let me go back to the PowerPoint that I was given in class. You can see here that is the actual formula to identify the test statistic. So now we'll move on to step 6. As I mentioned, check the assumptions with the associated test statistic. You can see the 3 steps here. So step number 1 is that p hat is distributed approximately normally, and you have to check that np0 and n1 minus p0 are both greater than or equal to 10. It's really important that you use the hypothesized proportion and not p hat, or else it will throw your values off. In this case, it's really easy since the proportion is 50%, so you can just do 200 times 0.5, and that equals to 100. Do that again. It's 200 times 0.5 equals 100. So 100 is greater than or equal to 10. So we can assume here that p hat is distributed approximately normally in this case. So the next step is to check that the observations are independent. So observations are independent. So for this, we have to make sure that no more than 10% of the population was sampled. So n has to be less than or equal to 0.1 n. So the n is the sample size that was given. So in a poll of 200 randomly selected voters. So that will be our n here. So 200 has to be less than or equal to 0.1 n of all sampled voters. So 200, so we can multiply actually by 10 on each side, so 2,000 is less than n of all sampled voters. So is 2,000 less than the number of all sampled voters? We can assume so, since most elections do have more than 2,000 people voting, so we can assume observations are independent. The third one we just kind of have to take on faith, and that's if the sample was randomly selected from the population of interest. And in this case, we have no reason to believe that it was biased. I'm running out of time here, so I will continue in the next video.